Open your student journal to page 72. What we're going to be looking at today are quadratics involving inequalities. So inequalities means that we can have less than, greater than. Okay, so those are two possibilities. In fact, up here you can see we can have y is less than the quadratic. We can have y is greater than the quadratic, or we can have less than or equal to, or greater than or equal to. When you were doing linear inequalities, can you remember what the difference was between the less than versus the less than or equal to? It had to do with whether it was solid or what? Open. Yeah, or dotted, actually, like for the line. Okay, so what we're going to be doing is, step one, we're going to graph the parabola, make the parabola dashed for inequalities that are less than or greater than, and it's going to be solid for inequalities that are less than or equal to or greater than or equal to. The next thing we want to do is we want to decide which way we're going to shade. Are we going to shade above for greater than, or below if it's less than? And then we're going to actually do the shading. So it's just a three-step process. Let's go ahead and take a look at some examples. So looking at these, the first thing we're going to do is we're going to put letter A into our graphing calculator. So get out your graphing calculator if you haven't already. And we're going to go to y equals. We're going to clear anything out that's in there now. Okay, so we're going to put in letter A, which is x squared plus 2x, and then minus 8. We're going to go all the way over here, and then it says less than. If you go all the way over here to the left, you can change the way the calculator graphs this. If I just go ahead and hit graph now, it just graphs the parabola. But if I go back over here and I go to this far left and I hit enter once, and then I come down here to line, I can arrow over. When we have a triangle like that in the upper right corner, that's greater than. That means greater than. If I go again to the right, it gives me this triangle. This triangle is for less than. Okay, so I want less than in letter A. So I'm going to go ahead and push enter and enter again. Can everybody get that triangle to show up like that? So now, when I hit graph, watch, let's do a zoom 6. Look what it does for me. See how it's graphing the parabola and everything underneath it? Are you able to get that to happen on your calculator? If not, I can help you afterwards. Some of the older calculators work a little differently. So which one does that match up with? Numbers 1, 2, 3, or 4? Number 1. So number 1 has to be letter A. Now, our goal is to be able to match these without having to put them into our calculator every time. So let's go to number 2. For number 2, do you think this would be greater than or less than? Are we talking about the points above or below the parabola? Above. So I'm looking for something with greater than. So I've narrowed it down to C and D because those are both greater than. This one is dotted. So which one would it have to be, C or D? C. Also, look at the coefficient of x squared. It's positive. Remember how that means it would open up? So this has to be letter C. Okay, you guys figure out the last two now. Which one's B and which one's D? So what did you guys put for number 3? Say it again. For number 3, you put B. Should be D for number 3. Because number 3 is greater than, it's above, so it's greater than, and also it's solid, so it would have to be, well, they're both solid, but it has to be D because it's greater than. This one would be all the points that are less than, so that's got to be the B. All right, let's go over to the next one now. So now we're going to do it on our own. Let's take a look at number 7. We're trying to graph this on our own now. So the first thing we want to do is graph the parabola. To graph it, we need to know the vertex. Michael, can you tell me the vertex? -4, -1, right? So that's going to be our vertex, -4, -1. Okay, so we're going to go ahead and plot that point, -4, -1. I'd like you to be pretty exact with your graphs. So what I'm going to do is I'm going to plug in a value. I'm going to plug in -2, and I want to know the y value. If I plug in -2, I would do -2 plus 4 is 2. 2 squared is 4, so I would have -4 minus 1. So that's -5. So I know at -2, I'm going to have to be at -5. Well, if I went over 2 and my answer was -5, I could also go 2 this way, and my answer would have to be -5. And so now I can make a fairly accurate parabola. I want to look here. This tells me it needs to be solid, so I'm going to make it solid. And then I have to look at what it's saying. It's saying all of the y values that are greater than the parabola. Am I going to shade above or below if I want the y values greater? Above. So all of this region then would be shaded. It's a little hard for me to shade with this. Yours will look a little nicer. So what that tells me is any point that lies in that shaded region is a solution. Any point in that shaded region is a solution. If it's not in the shaded region, it's not a solution. On number 8, again I have to find my vertex, but this one's not in vertex form. How can I find the vertex if it's not in vertex form? Holly? Okay, so I can do -4, -b over 2 times 4, which is 8. That gives me -1/2. To find the y coordinate, I have to plug it back in. -1/2 squared is going to be 1/4. Times 4 is 1. 4 times -1/2 is going to be -2 plus 1. Looks like an I. So what's the vertex then going to be? -1/2 comma, what's this? 0. So our vertex then is going to be at -1/2, 0. I need to find some other points. So at this point, I might want to plug in something like the number 1. So if I plug 1 in, I'm going to get 4 plus 4 plus 1. What does that give us? 9. So there's another point on my graph. So I'm going to go to 1. I'm going to have to make this go by 2s. 2, 4, 6, 8, 10. So 1, 9, I'm going to keep as 1, and then 9 would be right there. So I went over 1.5, and my answer was 9. So if I go over to the left 1.5, my answer also would have to be 9. I have to look at the inequality. Am I going to make it dotted or solid? Dotted. So I'm going to make a dotted inequality. Then I have to look at what it's saying. It says less than. So am I going to shade above or below the y's that are less than the parabola below. So I would shade all of this region. Okay. Any questions? All right. Go over to the next one. So on the other problems, we had just one inequality to graph. Now we have what's called a system of quadratic inequalities. That means we have two inequalities to graph. And we have to shade what works for both of them. Not just one, but both. On this one, I'm going to try to find the vertex. I would have to do negative b over 2a. That's a little bit complicated. Let me show you another way I can find my vertex. I can think of this as x squared plus 5x. I'm going to take half of 5 and square it. Half of 5 squared is 25 over 4. If I'm going to add 25 over 4 to complete the square, what else am I going to have to do? Subtract 25 over 4. So then another name for this would be x plus 5 halves squared minus 25 over 4. So what's the vertex going to be for that one then? Negative 5 halves, comma what? Negative 25 over 4. So I'm going to have to graph that. So I've got negative 2.5. And then negative, that would be like 6 1/4. So right about there. Down pretty low. All right, so I've got that vertex. Now I'm going to have to plug in a point. An easy point to plug in would be 0. If I plug 0 back into that function, what do I get? 0. So 0, 0 is a point. I went over 2.5 that way, so now I can go over 2.5 this way, and I'm also going to get 0. My parabola is going to be solid. Okay, so there's my first one. I'm going to shade above that one, so I'm going to use arrows like this just to show. I'm not going to shade yet, you guys, and you'll see why in a minute. I'm just going to tell where I would be shading. On my other one, my vertex is going to be at negative 2, negative 1. For this one, if I plug in 0, I get 0 plus 2 is 4, or is 2 squared is 4. Negative 4 minus 1 is negative 5. So at 0, I get negative 5. If I went over 2, I got negative 5. If I go over 2, I'm going to get negative 5. This one's going to be dotted. For this one, am I going to shade above or below it? It's less than the y's that are less than the parabola. Do I go above or below? Below. So remember what I said. We're shading the part that works for both of them. So I have to be above the first one and below the second one. Both of those two have to be true. Where am I going to shade then? In between them. Right in here. This is the only part that gets shaded. Is this part right in here, right in between them. That's it. Only points in that region are going to satisfy each inequality. Okay? We can also do these on the calculator. So let's look at number 12 on the calculator. So I'm going to go to y equals, clear out. If you hit clear twice, guys, that'll go back to a normal one. I'm going to do x squared minus 7x minus 8. I go over to the far left, and I want to be shading above it, so I'm going to push enter. Go down here, I'm going to arrow over, that's above it, that's greater than. So I'm going to push enter, enter. That's going to shade above that one. Put in my second one, negative x squared plus 6x plus 5. For this one, enter. And for this one, I want to be less than, so I have to have that symbol. I push enter twice. I'm going to do a graph now. And I would be looking for what makes both of them true. So the blue makes the first one true. The red makes the second one true. But can you see the region that's going to make both of them true? It's like our last one, isn't it? So what if I asked you, is the point 30 a solution to the system? What would you say? Mary, you're saying yes. Why? Right. 30 is in the region where they are both shaded. It's in like the purple region. What if I asked you, is the point negative 40 a solution? No, because that is not in the shaded region. Okay? Only points there are going to work. All right. Let's go over to the next slide. Now this is different, guys. This is not graphing. How do I know this is not graphing? What is the letter that you don't see? There's no Y. So this is not graphing. This is solving an inequality in one variable. Here's the way we do this, and this is different from anything you've seen, so you want to watch closely. To solve this, the first thing I do is I treat it as an equation. Just to solve for x. I'm going to divide by 16. I'm going to take the square root of both sides. When I do that, I get plus or minus 10 over 4. That reduces down to 5 over 2. Those are the values of x that make it equal to one another. If I were to plug in 5/2, it would equal 100. I want to know what are the values of x that would make it greater than 100. Here's the way we do it. I know that 5/2 makes it equal. I don't want it equal, so I'm going to use an open die. I know that negative 5/2 makes them equal. I don't want it equal, I use an open die. I now have to plug in a number in this region and plug it back into the original. It must go into the original. So I'm going to take negative 6. That's something there. Negative 6 squared is 36. Is 36 times 16 greater than 100? You don't need to know exactly what it is. Is 36 times 16 greater than 100? Yeah. So this works. This area works. That part on the number line. Plug in 0. If I plug in 0, is 0 greater than 100? No, those numbers are not going to work. What about positive 6? If I plug that in, is 36 times 16 greater than 100? We already said it was, yes. So writing the solution as an inequality, I would say my x value must be less than negative 5/2, or that x I choose must be greater than positive 5/2. Those are the solutions that make the inequality work. Can anyone tell me what it would be in interval notation? What do we call this down here, guys? So negative infinity to negative 5/2 union 5/2 to what? Infinity. That's going to be the solution. We have it written in both inequality form as well as interval notation. All right, number 14, I want you to change the problem slightly. Make your minus 34 a plus 34. And we're going to do this one as well. What do I do first? I have to let it equal to what? 0. So I'm going to have to say x squared equals 15x plus 34. First I let it just be equals rather than less than. Then I have to get it set equal to 0. We don't deal with the fact that it's inequality until the very end. We're going to change the minus to a plus 34. Okay, now we're going to go ahead and we're going to solve it. We're going to set up our double parentheses. We put our x and our x. What are numbers that multiply to be 34 and subtract to be 15? 17 and 2. We need a minus 17 and a positive 2. So our solutions then are going to be positive 17 and negative 2. Those are the values that make it equal 0. That's the values that make the x squared equal to the other side. We need a number line to figure out what we need, what values we need to have it work. So I'm allowed to be equal, so I use a closed dot to graph my solution set. I plug in a number like negative 3. Negative 3 squared is 9. Is 9 less than or equal to negative 45 plus 34? I'm plugging in negative 3. Is negative 45 plus 34 positive or negative? Negative. Is 9 going to be less than a negative number? No. So this region does not work. What's the easiest number to plug in here? Is 0 less than 34? So this region does work. Do you think that region is going to work? No, it will not. Guys, you can never have regions side by side that are going to work. It's always going to alternate. So if I find this one does work, that one can't work. So here's my solution set. Any x, as long as it's less than or equal to 17 and greater than or equal to negative 2. So any x that's in between negative 2 and 17 is going to work. To write that in interval notation, it's going to go from negative 2 to 17, and that again shows us that any value, including negative 2 and 17, is going to be a solution to that inequality. All right, the last problem we're going to do, and it's a tough one. Okay. The profit for a hot dog company is given by the equation y equals negative 0.02x squared plus 140x minus 2,500, where x is the number of hot dogs produced and y is the profit in dollars. How many hot dogs must be produced so that the company will generate a profit of at least $150,000? Okay, so where am I going to plug that $150,000 in for? Y, right. So I'm going to have 150,000, and I have the negative 0.02x squared plus 140x minus 2,500. What do I want this to be? It says a profit of at least 150,000. Do I want it to be greater than that or less than that? Greater than. I want this value to be greater than, right? Can it be equal to it if it says at least? Yes. Now, I could solve this algebraically, but can you think of how difficult it would be to do that? We're going to do this on our graphing calculator, and it's still not going to be easy, but we're going to try it. Okay. So we're going to go to our calculator and we're going to type this in. Hit enter twice to get rid of or hit clear twice to get rid of the inequalities. I really don't even want an inequality. I'm going to put 150,000 in for y sub 1. I'm going to put in the next part of the function. Now, guys, the window. I am going to have to change this window dramatically. Because what am I trying to see? 150,000. If I go from negative 10 to 10, I'm definitely not seeing 150,000. So I am going to go to Window, and I'm going to make this Y max. It has to be 150,000. So I'm going to make my max like 250,000. I have no idea how many hot dogs we have to make, but I'm going to make it like, it's going to be a lot, isn't it? Probably, let's go with 2,000 and see what it looks like. Hit graph. There's 150,000 we want to make. There's our function. We want to know, where is our profit above 150,000? What am I going to have to do to see it? I'm going to have to change my window. Make another prediction. What should I make my X max? What do you guys think? It was close. It was almost to the vertex. So what should I make it? 5,000 is a good one. It may work, it may not. Let's see. There's our 150,000. Here comes our parabola. Oh, so close. Make it a little bit bigger. Let's just go way big. Let's go 10,000. So there's the 150,000 mark. There's our profit function. Where am I looking then? Would I be looking in this range, this area here, and this area here, or am I looking up there? Above, right? These are the profits that are above 150,000. What am I going to want to find then? The points of intersection. So second, trace, calculate, intersect. Get over there close to the first one. Enter, enter, enter. So as long as we make 1,000, let's do it like this. We'll say X is our number of hot dogs. So if the X value we make is 1,349, okay, now think about this, guys. It's 1,349.4. If I make 1,349, am I going to be above that $150,000 mark? I'm going to have to round this up, right? Even though it really rounds down, I'm going to have to take it up to 50. I can't make a partial hot dog. No one's going to want to buy that. If I make half a hot dog, nobody's going to want it. All right, now we need to find that other point. Find it for me. Get over there close to it. And I get 5,650.5. Now, we have to think, are we going to round this up, as it seems like we should, or round it down? Why down? You're right. Yeah, if I round this up, I'm actually lower than the $150,000 mark for the profits. So I want to make this 5,650. So as long as the number of hot dogs we make are in between that, why might it be if I make 5,651 hot dogs, all of a sudden I'm not making a profit? How could that possibly happen in the real world? Yes? Exactly. If it's the middle of winter and no one's out by a campfire roasting hot dogs, you may not be able to sell that many, right? So you make all these hot dogs and nobody wants to buy them. That's how that could happen. All right? You get the idea of that? Yeah. Very good, guys. Okay, we'll go ahead and take a look at the weeklies. Get out the weeklies.